I am Ayman Sharkawi, and I'm happy to moderate this afternoon sessions as well. This morning, we enjoyed some very insightful remarks from a series of high-level panelists, experts, and I'm happy to say that this will continue this afternoon. For this particular session, we will be discussing the industrial dimension of Power to X. And to chair the conversation for this session number 3, we will enjoy a chairmanship of Mr. Rachid Idrissi Qaitouni, who heads Africa Gas, as well as the gas department in the AFQA Group Holdings. So, without further ado, I am pleased to leave the floor to Mr. Qaitouni.
Thank you. Thank you, Mr. Ayman Sharkawi. I'm extremely honored to share this session 3 dedicated to the industrial deployment of green hydrogen and Power to X. Indeed, green hydrogen will most likely play a major role in the integrated energy system of the future, alongside renewable electrification and a more efficiency and circular use of resources. A large-scale deployment of green hydrogen solution at a fast pace is key to counter climate change and reduce greenhouse gas emission in a cost-effective way. This ambition represents one of the biggest industrial challenges of the current decades. This concerns different renewable energy sources: intermittent, solar and wind, continuous, hydro, geothermal and biomass. From different technology, power to hydrogen, power to fuels, power to ammonia, and for different products and application: mobility, fertilizer, power plants, long-term storage, chemical feedstock. Morocco is ideally placed to produce green Power to X products to address both domestic markets and export. In this session, the panelists will share their experience tackling the challenges of scaling up technology, especially the electrolyzer industry. They will also give their insights on how to turn large infrastructure development projects into profitable and positive investment decisions. The panelists will also share their views on creating the right synergies between the key players of the Power to X value chain and their impact on the distribution network, storage, facilities, and supply logistics. For this matter, I'm glad to have with me today the distinguished panel, Dr. Catherine Goldamer, Managing Director of Renewable Institute, is there. Mrs. Nadja Hankinson, Managing Director, Region Africa from Siemens Energy Service Industrial Application, Mrs. Karen Hillinger, Chief Commercial Officer from NG Hydrogen Business Unit, Mr. Christopher Frank, Head of Strategic Business Development and Key Account Management, ThyssenKrupp Industrial Solutions, Mr. Florent Baudu, Sales Director from McPhee, Mr. Raphael Tilo, Renewable Director from Cockerill, and the last but not the least, Mr. Denis Thomas, Global Business Development Leader from Cummins Incorporation. We will start this keynote from Dr. Catherine Goldamer, Managing Director at Renewable Institute and board member of the German Hydrogen Alliance, EPOS. Dr. Goldamer is an energy market expert with a special interest in energy policy, stakeholder involvement in politics and transdisciplinary approaches to knowledge generation. She is the Managing Director of the Renewable Institute and Energy Research Institute in Germany.
Hello, everyone. And thank you, Mr. Idrissi, for the kind introduction. It's great to see you, although we can't meet in person, but we can meet in this conference. And I'd like to thank you for the opportunity to be talking a little bit about the learnings that we have had from green hydrogen projects in Germany. And because this conference has already highlighted a few of the German issues that are very important right now, I think this would be a very good match to see from my applied energy point of view how this translates into practice. And then in this session, you're going to hear from many other practitioners how they see the whole idea of the large scale in hydrogen, the industrial deployment. This is what we'd like to talk about in this session. What I've compiled for you is a little bit of history about the research that I've done and also the work that I've done as a board member of HYPOS, so that you know from which perspective I'm talking about green hydrogen projects. Generally, what you need to know about my institute is that we have a legacy, and the legacy is the one of Rainer Lemoyne. And you might have not have heard about him, but he's a German engineer who unfortunately died very young, but he was one of the pioneers in renewable energy already in the 60s and 70s. And he founded two very famous German solar PV companies in the 90s, which basically earned him a lot of money, and he turned this into a philanthropy. And we are doing the nonprofit work from a research perspective that Rainer started as an engineer. Likewise, at my institute, we're all engineers. So my perspective is usually from electrical engineering, from computer science, mechanical engineering. And then we're looking into, deploying these technologies. What does it mean cost-wise? What does it mean carbon-wise? Because we're committed to a future with 100% renewables or a net carbon-free. I'm also today representing the HYPOS network. And this is an important player in the German hydrogen field as well. So this is why I'm also introducing you to some of the projects that we're doing at HYPOS. Hydrogen research at my institute, if you want to picture what we're doing, is basically something that taps into the idea of 100% renewable energy in the future. So for example, hydrogen in power to X always comes into our energy system modeling. Green hydrogen can be part of the energy supply for Germany as a region. We're also looking at the interplay between power to X and other kinds of storage. So for example, if you see hydrogen coming up in the transport sector, this will have an effect on large-scale storage, which you will need for the electricity sector. And coupling all these sectors together in esteemed energy system models, that's what we're here for. We're also looking at generally the effects of these technologies on carbon emissions, investment costs of energy systems, and so on. Green hydrogen production, though, is also something else. It's also to look at the on-site electrolyzer, its different dispatch options, and so on. And we have a focus on hydrogen and power to X in the transport sector. So for example, we're comparing battery electric vehicles and their impact on the energy system to what you would do with a fuel cell vehicle. And then the fuel cell vehicle is not the only transport option we look into. We've also conducted a few projects with fuel cell trains and ships. And this can be a study and it can be an application depending on the degree of readiness. For example, when you look at fuel cell trains, the readiness level is very different from the one when you look at for example. This is something that I'd like to show you because it shows you a little bit of the discussion that we've had in Germany over the last few years. So for the Federal Ministry of Transport in Germany, we're working on a location tool for whole of Germany, and we're trying to facilitate the transformation of the transport sector. In our case, our job is to look into hydrogen and alternative to natural gas, but our partners are looking into what could be the best location for the charging infrastructure of the future. And it shows you that when we're looking into alternative transport, hydrogen is playing a part in this area in Germany. We're not only looking into battery electric vehicles, but also into hydrogen. And one of the first projects that we did is in a way a famous project because it is related to this famous new airport in Berlin that we've had. Well, and we've been building it for a very long time. You might have heard the news about it. It was supposed to go online almost 10 years ago. And now finally, this year, amid the Corona crisis, we have opened a new airport in Berlin. Several years ago, RLI was already supplying, together with partners, this airport with hydrogen, and this was on-site electrolyzer-based hydrogen. The idea at the time was the new airport will probably need a new public transport line. Why not give it a hydrogen bus to supply the airport line? So we were setting up at a gas station that Total owns. We were setting up a new kind of electrolyzer. And the idea was that the new airport is situated in Brandenburg, which is a federal state with a very high share of renewable energy. And this could be a predecessor for new projects where you take on-site electricity generated from renewables and then feed them into, for example, a well-running gas station like this one. As you can imagine, this one, as it came online, practically the hydrogen part at least, had to go offline for another few years because it wasn't a very well-used hydrogen supply station at the time. But I'm lucky to tell you that now finally, since the airport is online, I think we're going a great step from this one. And since this is about scale up of technology, I've also taken this example that I wanted to show you because we've also actually developed new electrolyzer technology. And the idea behind the project that we did here was, obviously, if we're honest, electrolyzer hardware costs are always and still the most expensive part of the investment, right? So is there any way to drive these costs down? And at the time we were thinking, can we work together with the automotive industry? Because you know that the automotive industry in Germany is extremely strong, extremely efficient. And we were thinking, is there, let's say, a processing or a production knowledge that we can use from this industry to maybe produce a new electrolyzer that we can scale up in such a way that we can help all these industrial deployment issues at some point in the future. And we've developed a prototype which comes as a very, very small scale electrolyzer. And we were thinking, you know, this could be great for basically sending it up in small remote situations. This could be an off-grid site, for example, or you could plug them together and make them modular. And since I'm also representing HYPOS, this is something that you should know about the network that we're in. So HYPOS is the hydrogen power and storage network in the region that I'm going to show you on my next slide. The idea is that we're combining the knowledge and also the mission of more than 120 members in Germany, but also abroad, working on a green hydrogen economy. We're very keen on the green part, and I can explain to you why that is. Generally, the idea is that the whole value chain should be part of the transformation of the hydrogen economy. So, for example, we're both looking at the production, and I'm talking renewable electricity production. I'm not only talking hydrogen production. This is not where we start, but we're starting at the renewable energy. And then we're looking at production, storage, transportation, and utilization. Why is HYPOS especially well situated to do this? Well, this is a map of Germany. You've probably seen it before. In the area that is highlighted on the east, this is more the area that HYPOS is active in. And it's an area that is very famous for its chemical industry. It has a long history of chemical industry in the area, and it also has one of the two H2 pipelines that we have in Germany. It's not like it's a country full of hydrogen pipelines, but we have one dedicated hydrogen pipeline in this area, and it supplies some of these chemical industry sites that I've just mentioned. And what's also interesting to know about this region is that the supply of renewable energy already, but also in the future, will be massive because it's prone to a lot of wind and so on. And it's also not a densely populated area with a lot of industrial production. So there is going to be a surplus of green electricity coming up in the future in this area. And we're thinking it will be a great synergy to turn this into green hydrogen and make it use in the industries that are here. We're looking, as I said, at all the different phases of the value chain. And what's interesting about the value chain is that I also mentioned that we're looking into large-scale storage. So we're not only thinking, you know, decentralized small scale or putting it on a truck, but we're actually having, we've developed a few projects with a natural gas network operator tapping into their storage facilities, into the caverns, and looking what hydrogen will do to these storage options. And then when it comes to the utilization of hydrogen, from my German perspective, I am open to all these different kinds of deployment methods. I can see hydrogen coming up in the transport sector, as well as the chemical industry, the industry in general, energy supply, and so on. And I think we should talk a little more later of maybe how you would see this in Germany or in other countries coming up. What are the areas or energy sectors where we're actually going to be using hydrogen first? I look forward to your opinions on this. So some of the projects that we have, they can be as big as this one, like a large hydrogen storage facility, but they can also be a large-scale electrolyzer that we're aiming to set up. And HYPA's, if you want to imagine what we do, is the facilitator in most of these places, and sometimes we're part of the project. We're also looking into fuel cell trains in the region, or logistics projects, or projects with the smaller municipalities in the area. And I'd like to conclude my, my short presentation with a summary of what I've learned from our projects when it comes to three major things: the industrial deployment and the challenges, the question how we can make these large infrastructure development projects more profitable, and also the synergies or the interconnections between those areas. So from my German perspective, the industrial deployment of Power-to-X is something that I'd like to see in the future, but it's not really there yet. What are the reasons? I see a challenge in the regulative framework that we have, and it basically has to do with everything that can drive investment costs down. That comes from a regulative perspective. Obviously, investment costs can also come from technology development, right? So development of technology will probably profit from the fact that it's being deployed. So the more large-scale facilities we're seeing coming up, the better the investment costs are going to be. But also the regulation in Germany is very important. We've been discussing for a very long time how we can make green hydrogen particularly interesting. And we've just decided, as one example, that if you want to turn electricity into hydrogen and it's all green, you are stripped of a few of the very heavy charges that are usually added to energy consumption at the consumer level. This will obviously make a big difference, right, when it comes to producing green hydrogen. And I also think it's an issue of timing. So whenever the electricity surplus is very high, when the price volatility in Germany is going to be very high, there is more making use of turning electricity into green hydrogen and storing it as hydrogen. When it comes to profitability, I still want to mention that, you know, generally from a bird's eye view, carbon pricing will probably play a role too, right? Green hydrogen is only as attractive as, you know, fossil fuels are unattractive. So this is something that would make a big difference. And I think internationally we should discuss this. And then carbon targets for the industry in Germany and the transformation of industrial processes to a decarbonized industry, that would really play a very big role in Germany as well. And what I'm particularly interested in is the synergies or the effects of Power-to-X on the energy system, because we're running all these energy system models, right? And in our scenarios, it makes a very big difference if we consider, let's say, 45 million passenger cars being battery electric, or half of them being fuel cell cars, right? Because the amount of hydrogen that needs to be produced for this could have a great effect on the electricity system. So my first point is it's going to have a great impact. And my second one is, obviously, it then makes sense to develop electricity systems and a hydrogen system in a close synergy. You know, have an idea of what your hydrogen future will be like, and then try to develop electricity systems alongside this idea, because it's going to save you a lot of sunk investment in the future. And with this, I'm closing my talk. Thank you so much for your attention.
Thank you, Dr. Goldamer, for this insightful presentation. We will move now to Mrs. Nadja Hackenson. She is the Managing Director of the African region at Siemens Energy. She is responsible for leading the Energy Services Unit for Siemens Energy in Africa, where her priority is to grow the business and optimize the organization. In addition, Mrs. Hackenson focuses on developing skills and capability locally across the continents. Go ahead, please. Micro.
Oh. Can you hear me?
Yeah.
Perfect. Thank you, Mr. Idrissi, for the warm welcome and introduction. It's an honor, a pleasure to participate in this important event today, representing Siemens Energy, and very much interesting sessions prior to this one, I must say. And I'm very honored since we as Siemens Energy are an important contributor to realize. So I don't know what happened there with the noise, but I hope it's better now. I want to start by maybe just explaining a little bit what Siemens Energy are all about. I think Siemens is quite well known for the most of everyone listening at the moment, having a long history and a broad portfolio. Actually, today I would say that with our newly formed Siemens Energy company, we actually represent the whole value chain and are a great mirror, actually, of the current energy landscape, having our traditional portfolio of gas turbines, steam turbines, compressors, our power generation, our industrial applications, our transmission business, of course, our renewable business through Siemens Gamesa, which we also support via the transmission and steam turbines. So we really represent the whole value chain of what you see in the world today, which is very exciting, right? And we also have a division named New Energy Business, which is really focused on the products around hydrogen. So through our New Energy Business, we can provide the technology, the systems and solutions to enable the production of hydrogen and its derivatives through our electrolyzer technologies. So through Siemens Energy, of course, having that whole portfolio, we can accompany and support the society on this mission of decarbonization, which is very much what we have now in focus, and it's very important for us all to contribute with. This slide is a really good visualization of the concept of sector coupling. So because if we think about it, why are we aiming, why are we talking today so much about hydrogen? Why is this such a trendy topic that we're all focusing on? Well, of course, obviously, we believe, just as many, that hydrogen is going to play an important role for the deep decarbonization of our world, right? And why hydrogen? Well, because through hydrogen, it enables a large-scale application of hydrogen. Sectors that today cannot use fully renewable energy that is generated locally in a decentralized area. And this is because hydrogen is such an excellent carrier of energy, which enables transportation, right, of the green energy to other sectors, enabling mobility, industry, heating for houses, etc., etc. So it opens up for a completely new revolutionized in energy landscape. So sector coupling is all about the close integration of the power generating sectors with the power consuming sectors. You could say that it's really creating a mix of different solutions that today exist as sort of standalone, and putting them all together. So that's completely new, combining existing energy solutions into an ecosystem. And with this slide, my main key message is that we are really on a journey. we are on a development journey, scaling up from test application, which we started with the electrolyzer, the Electrolyzer 100 already back in 2011. So it's quite many years in R&D and development, right? So now it's all about scaling this up. So what is needed is to move from smaller test scale, lab scale demos to more larger scale pilots to really demonstrate that these R&D developments and theoretical aspects of what hydrogen can do can really be tested in a real live system. What we as Siemens do with our Electrolyzer technology is that we focus on the PEM electrolyzing technology, which PEM stands for proton exchange membrane, which makes us quite unique because PEM is highly flexible and adaptable when it comes to the volatility and intermittency of the renewables. So with this time scale, I'm sure we're going to talk about that. You know, it's quite an ambitious time scale, right? But we are quickly moving towards 100 megawatt projects, right? It's our belief that we can do that in a fairly near future. And the ultimate vision is, of course, the 1 gigawatt perspective that we envision. What I want to mention, I mentioned initially that we mirror perfectly the current energy landscape, and we have a broad existing fleet already of our conventional technology for energy. And we believe that natural gas is still going to play a role as a transitional technology through our gas turbines. And what I want to show with this is just a few of our gas turbine models that we are actually already today able to run on hydrogen. So we are really focusing on making the existing conventional technology future-proof, future-ready. So the ultimate goal also here is that they will be able to run on 100% hydrogen, so really ready with our technology for the hydrogen economy. So with that, I thank you all, and let's move to the next.
Thank you, Mrs. Hackinson, for this interesting presentation from Siemens. We will move now to Mrs. Karen Hillinger, is the Chief Commercial Office of Hydrogen Business Unit at ENGIE. She develops green hydrogen innovative solutions for large-scale industrial customers around the world. Prior to her current function, Mrs. Hillinger oversaw business development at ENGIE Fab, the innovation factory of ENGIE. She's developed disruptive large-scale new businesses in the entrepreneurial fashion, anticipating the technologies of tomorrow. Please go ahead.
Sorry, I needed to unmute. Thanks a lot for this very kind introduction. Thanks a lot also for the invitation to this conference. I'm really happy to be with you this afternoon. Today, hydrogen is alive, and within ENGIE, and together with a lot of partners and industrial, we make it happen. The topic of this afternoon is about the challenge we are facing toward the scale-up of the Power-to-X value chain. I would like to turn it on into what are the opportunities to make it happen, because behind each challenge, it's an opportunity, and it's really essential. The first element I wanted to share with you, and I will comment on what has already been said this morning and right today, it's about being at the crossroad of a huge momentum. And it's a few elements. What we can observe today is that there is a massive collective commitment on the energy transition, and the support and the contribution of hydrogen is really recognized in that. If we sum up all what is being proposed now as support mechanisms, it's about tens of billions. It's mainly driven by Europe, but also massively by Australia with almost 20 billion, Chile, Japan, and soon Morocco, I'm sure. We are also now seeing the structuration of the sector to materialize a strong pipeline of concrete projects, of which something completely new, the average size is 100 megawatt, as it was also just mentioned. So it's scaling up is getting the reality. And on the electrolyzer supplier side, we see this integration of the scale up. And just the setup of the panel this afternoon is highlighting it. Another added value of hydrogen, which I would like to add on what has already been said, is the fact that hydrogen is contributing to the energy transition, but also, and even maybe more important, it's contributing to the local economies, and it will boost local economies. So it's a real investment for the future, starting today. What are the concrete things that we need to make a reality as of today? It's 3 opportunities. It can be seen as 3 challenges, but I would rather take it as opportunity. First, it's about sorry for this. Okay, so first of all, it was big momentum. What are the 3 key elements? First, it's about the competitiveness of the renewable hydrogen production. If not competitive, it will never make it. Second, it's about regulation. And third, it's about having the good financing and support mechanism. The 2 later one being really in balance. Let's touch about the competitiveness. Today, producing hydrogen via electrolysis is double the price than via fossil fuels. In some good cases, we can reach out parity soon if we are in some specific area. What are the key elements to drive this competitiveness down? We have 2 of them. It's about having access to the cheapest renewable energy with the best load factor. In that context, and you can see it on the small map above here, Morocco is wonderfully well positioned. Second aspect, it's technology cost reduction. Again, the panel today is really putting that into the spotlight, and they're working on it, and they see it getting materialized step by step. The second element was about regulation. And the third one was about having the good support and financing mechanism. Let me take both of them together. The good news in all the support and regulation which is being put forward, it's about scaling up. It's about large scale. So it's about supporting big steps instead of a lot of small steps. And that's where we are in. Very concretely, how can we make it happen? In this support type of mechanism, we are convinced that we need to play on all the part of the value chain. On the supply side, having contract for different type of mechanism to offset temporarily, and that's essential, temporarily the gap between the cost of carbonated and decarbonated. On the other side, the end of the value chain, on the demand side, introducing specific target, supporting the offtake is really essential. And to support the entire value chain is having a concrete roadmap with concrete milestone to be able to decarbonize the energy sector. So what we see here is really a rapid structuration of the market to reach those ambitions. What do we do at ENGIE? Here you see a slide. It's a bit of a collector slide, as it was it dated back from 2016. The good news is that now everybody is sharing this vision of producing in very good region, having local offtake, encourage with the industry, with the mining, the heavy mobility, and then at a later stage, exporting this renewable energy to location worldwide where there will be a lack of this renewable hydrogen. This vision, ENGIE is really putting it into actions with a portfolio of 3 gigawatts of industrial scale project at more than 10 different countries worldwide, and on the different axes of different sectors, as you can see. Now, concretely on what scale-ups requires and what are the key lessons learned ENGIE is willing to share from this pipeline of development. We have 5 of them, and we can take them in different order. For us, what is essential is having offtake, building the offtake. That's really the basis of how we think we can trigger this scaling up. For sure, we need to have the design of integrated solution. We have to have the technology at the right size, and that's something which is being done by the entire industry, partnering together to make it happen. For sure, that's essential. Sometimes we forget it takes time. The permitting part, the health and safety, is also very important, and also because it integrates different bricks. It's about renewable electricity production. It's also about the transformation of it into a renewable gas, and then the end use of it. Having the investor ready to invest, making it a bankable project is for sure essential. And on top of it, or to start with, it's about having the good support mechanism, having the political willingness, the vision to make it happen, to be bold, to take big steps and set up the good regulatory framework. So if to conclude, I would like to say that from our perspective, we believe that Morocco is fulfilling all the success factor or the key lessons learned of the project we have recently been developed to be at scale, to be at the rendezvous, to be able to decarbonize the industry, benefiting from the renewable and with the opportunity to export this renewable energy. And at ENGIE, we are ready to engage, to join forces into consortium to go for this development of hydrogen project in Morocco. Thanks a lot for your attention. And the last word, tomorrow is today. So let's build up those consortium to make it happen. Thanks a lot.
Thank you, Mrs. Hillinger, for this insight from ENGIE and a nice word for Morocco industry. Our next speaker, Mr. Christopher Frank, is the head of strategic business development and key account management at ThyssenKrupp Industrial Solution. ThyssenKrupp is a leading partner for the engineering, construction, and service of industrial plants and systems. He's responsible for the implementation of the further enhanced key account management practice for the entire process technology portfolio of the company of the Middle East, Turkey, and Africa. The floor is yours. Mr. Christopher, the micro, put on the micro.
Thank you very much for that hint. Yeah, it helps a lot to have a microphone open. Yeah, thank you very much for giving the nice introduction and for giving me the opportunity to introduce what we as ThyssenKrupp are doing. While we've learned in the previous presentations that it's important to convert future markets for hydrogen as an energy carrier or other energy carriers coming from hydrogen, from green hydrogen, or setting up, of course, the necessary green power generation, we at ThyssenKrupp Industrial Solutions feel a bit more like being kind of a machine room to make all that happen. If you look at the energy demands on hydrogen and compare it to what is used currently in Western Europe in form of natural gas imported energy, if you would like to store that natural gas provided energy in batteries, you would probably need 1.2 billion Tesla cars in order to store all that energy, just to give you a grippy thing. So we're focusing on how can we contribute to accelerate the developments into a green energy society. We are convinced that this is also this is necessary here in Europe and elsewhere in the world. It is also very important that we make energy transportable. And hydrogen, to transport hydrogen is possible, of course, via trucks to a certain extent, much better via pipelines, but also even better via chemicals. And I'm coming to that a little bit later. Let me see how I can flip the screen now. Here we go. And we had that earlier already in one of my predecessors' presentations, that we have that we are targeting for a circular economy. Yeah, and I think what is absolutely needed is a cross-industry coupling, using waste streams like CO2 emitted from furnaces, from other chemical processes, etc., and combine that with renewable energy and produce useful things out of that, such as monomers, plastics, or olefins, for example, or methanol as an energy carrier, ammonia as one of the base chemicals that is very important in our food security. Yeah? Ammonia is the base product for most of the fertilizers we use today to feed the world. However, ammonia is also one of the key commodity chemicals to produce mining explosives via ammonium nitrate. We heard it on the ENGIE presentation earlier, that one of their projects is also for the mining industries. You can convert complete industries into a CO2-free industry. However, it requires large-scale investments, and not only into the electrolyzers, for example, to start with, but moreover into the provision of the generation of renewable energy. And I think that's what I wanted to demonstrate with my earlier example. The energy demand just of Western Europe is huge. And that has to come from somewhere. And also the German government is convinced that it only will work for Germany, at least, when we import green energy from somewhere. And of course, one of the elements, the key element to produce green energy is hydrogen. I think we are all aware of that. What we've done is we used our expertise in coming from the caustic or alkaline or chlorine plant technology from the electrolysis chloralkali technology. And we converted that and refined it and rejuvenated our technology to, let's say, a world standard technology which can be applied to many cases and is also very flexible. It's a pretty old technology, in fact. The first hydrogen-based ammonia and nitric acid and ammonium nitrate plant has been built by us in the 1960s already. Now went into operation in 1965 and in Peru, and it's still operating there. So what we did is we need to commercialize that, and we thought that standardized modules are the relevant modules because it's easy to apply and can easily multiplied. So we have a whole variety of electrolyzers, but we focus on 20 megawatt electrolyzer units that can be combined then by just multiplication into larger plants of any size. And right now, some of you might have heard it, the first mega projects are developing there. Air Products recently announced a cooperation with us in Saudi Arabia, where the intention is to produce hydrogen coming from 2 gigawatt electrolyzers. This is needed, in fact, to in that particular case, to produce ammonia, which then is going to be transported to Europe as an energy carrier or as a commodity chemical carrier, which is important because at the end of the day, I think we have to change the whole value chains of the chemical industry, not only for the mobility sector, but also for all kinds of other applications of our daily life, like fertilizers, plastics, etc. This slide gives you a little overview of what's going on at the moment and what is possible already. There are various types of producing chemicals from renewable sources. One is, of course, biomass. You can gasify biomass and convert it into Fischer-Tropsch and upgrade it and produce diesel, for example, out of that. That's currently done in Dunkirk in France, where we're in a partnership with Total and Axens for a demonstration unit there. Disadvantage of biomass gasification, we all know that is, of course, you need biomass, and that's in competition with food in many cases, at least. Yeah. So we see a market for that, but the quantities we don't see at the moment. The majority really comes from renewable electricity and water electrolysis. Also there, you can split the hydrogen into various applications readily available at industrial scale already. So there's no need, in fact, as long as the hydrogen production facility is reliable, to go into pilots plants. Why? Because all these downstream technologies are well proven and have been applied multiple times globally. Methanation, for example, methanation process is applied in every ammonia plant. Methanol synthesis, that's done as well. The catalytic side, of course, is a bit tricky there because you only have 2 reactants available in green methanol, which is CO2 and hydrogen. The CO is missing there. But that catalytic problem has been solved and has been tested in demonstration plants already. Ammonia synthesis is clear, hydrogen and nitrogen. Nitrogen could come from an air separation plant, which is also a standard application. So let's say the technical possibilities to implement national strategy to convert industries into a green industry, that is to a very large extent all given already. It's no rocket science any longer. It can be built, and it can be built even on a lump sum turnkey basis if wanted. Why am I saying that lump sum turnkey or EPC? Because at the end of the day, it's necessary to finance such projects. And we've learned earlier that yes, the competitiveness is clear. It needs to be competitive, otherwise no one will invest. And that is something which I think the governments, the lawmakers really have to focus on. That they set up legislation that permits investment into such technologies. That trade of energy coming from either pure hydrogen or chemicals as an energy carrier or as a regular commodity product, that trade is not prohibited or full of obstacles, but is as easy as possible, that no further costs are being added. That there's a fair competition, meaning that not some producers polluting or continuing to pollute the atmosphere have advantages over non-polluting production technologies. All these aspects are, of course, sensitive elements, and they affect a lot of different societies and countries and governments. And I think the tricky part, the most tricky part, has been successfully passed already. That was the Paris Treaty. And if we then, at the end of the day, would come to, let's say, a globally aligned legislation framework, which is transparent in order and provide guidance to the investors. Sometimes it's very complicated to apply for, let's say, initial upfront financing or governmental support. It is a nightmare to apply for that for regular investors. They want to do things quickly, and application for governmental aid is really time-consuming. I think all of my pre-speakers would certainly share that view. The endurance of policymaking is very important in order to bring things forward. It needs incentive mechanisms also to attract investments, which at the end of the day will pay back by more jobs, by converting an industry, by maintaining jobs, and thus, of course, maintaining tax flow or tax money flow to the governments. It will need political will. And I think what is definitely needed from our perspective is that the global governments need to accelerate pace in a dramatic way. We are far too slow. Technology is ready. That's what I wanted to see, to show you, to demonstrate to you. The setup for building projects is there. The competitiveness, and I could elaborate more in different slides on production prices for ammonia, for example. It's all related to the power price. We've seen projects in the Middle East. Of course, yes, they have a lot of sun, where the kilowatt hour price is guaranteed at 35 US cents per kilowatt hour in the production cost. And I think at that level, we are already now competitive. Further developments, of course, have to be done in terms of efficiency of the electrolyzer cells. That's a continuous process, not only with our company. I'm sure that Siemens and others are working on that heavily as well in order to bring down the investment cost. But without the political will, without governments being aligned and not only thinking in 4 years legislation timeframes, then I think we have all chances to accelerate matters and to become a greener society, to live in greener societies in the future. And with that, I end here, and thank you very much.
Thank you, Frank, for this input from ThyssenKrupp. Let me please give the floor to Mr. Florent Baudu. He is the sales director of McPhy, where he is in charge of the development of large-scale decarbonate hydrogen solution for the industry and hydrogen production via megawatt electrolyzer. McPhy is a designer, manufacturer, and integrator of hydrogen equipment, which has 3 development, engineering, and production units based in Europe. Please.
Thank you very much. Okay, sorry for the echo. Thanks a lot. Indeed, and this was mentioned by the different presenters just before. What we see at the moment is clearly a great momentum in the hydrogen world. And that is quite unique. What I would like to remind, it was somehow touched base by the previous presenter. The hydrogen is actually a unique opportunity for all the actors of the ecosystem and for the states as well to be a front runner in a pioneering technology, to bring growth, local employment, and also to develop added value skills on the territory, which is very important. As well, to participate, and that's the basic of it, but to participate to a healthier and a cleaner future for the next generation, which I believe is one of the essence of all the efforts we are doing at the moment. Indeed, on the hydrogen world today, the motto is clearly scale up. Sorry, I have the echo. Strange. So indeed, the motto is scale up and scale up and scale up again. And the roadmap for bringing the hydrogen, the green hydrogen, to a cost down is clear, and you can see on the slide, by the way, the targets, which are quite well known and quite shared by most of the actors of the ecosystem. The successful scaling up is indeed key in this industry to allow the massive industrialization, which will lead ultimately to the adoption of the technology. Having the technology, having the technical issues is fine, but having the technology being adopted is the most important target we have to achieve. This will also be based on real projects which have to be implemented. We will have to learn by doing. The different stakeholder of the industry will have to learn by doing. This is the essence of the know-how, which will participate to the adoption of the technology. Of course, we will also, by scaling up, drastically reduce the capex and optimize as well the opex. At the end of the day, what we are all looking at is the total cost of ownership of the hydrogen molecules to go down and to reach the competitiveness level that we are all targeting. Last but not least, it will also allow the crystallization of some industrial standard specifics which are not yet existing for this industry, which will have to be set and which have to become the real standards. And we mentioned briefly, but the safety standards, for example, are one of those industry specifics which will be growing up and which will be established when we will scale up all the industry. But of course, this will require all the actors of the ecosystem to be at the rendezvous. And speaking about this, I would mention the investors and the industrial players, which shall not be too risk averse. Of course, all the points being of who will be the front runner, who would be the followers, and who will take the risk. But to develop it, there will need to be some players which will not be too risk averse. Then, of course, the public authorities, which will have to support by initial fundings mechanism and also by regulatory frameworks to allow the industry to quickly reach the right competitivity level. They will have to light the flame, if I might say so, even though in hydrogen world we have to take care by lighting the flame, by the way. But that's important. And then, of course, the equipment and the solution suppliers, as we are, we will have to be very straightforward. We will have to sweat blood and tears to reduce the costs, the TCO, as quickly as achievable, with no compromise on the engineering standards and on the quality standards as well. And this is very important. Those three pillars I just mentioned before will have to work in conjunction and cooperation, and they will have to put what might appear from time to time like some short-term contradictory interest. But we see also today that this works, and we see those three pillars and those three main side of the actors which are working together, which is very positive. Of course, within the path for scaling up, the large-scale pilot project will drive concepts to a tangible reality, and they are of primary importance. I present you on the slide the case of the Jewels project, which is under execution, which is a 20 megawatt electrolyzer, which will be installed in Netherlands, which will avoid 27,000 tons of CO2 per year, and which will deliver 3,000 tons per year of green hydrogen for methanol synthesis. That will be the biggest one in its kind in Europe. And this one will be led by a consortium with Nourion Gazuni and 6 other members, McPhee being the electrolyzer suppliers in this case. With this project, we will be able to a real scale operational validation of the concept, also OPEX optimization while starting the unit and really operating the unit. And we will also have to, because you see on the slide that this electrolyzer will be implemented in the middle of a chemical cluster in Northern Europe to hit the highest safety standards, which will be of main importance again. Then, of course, for the electrolyzer or refilling station supplier, this will require the anticipation of long-term visions for the adapted industrial capacities. As example, as you can see on the slides, we at McPhee have already available the manufacturing workshop capacity of 100 megawatt to 300 megawatt, 100 megawatt with one shift, 300 megawatt with 3 shifts, easily scalable to 600 megawatt, and as well some gigafactory investment to be confirmed in 2021 to reach gigafactory capacity totally of 1.3 gigawatts by 2024. Matching the timetable between the supply and the demand will be a key issue while developing the whole ecosystem and making the hydrogen world being tomorrow the leader of these new technologies and decarbonated world and industry. Again, this is great momentum we are all living, and this is unique opportunity to build this new industry. And we have to make that in an environment which is socially responsible, and of course, keeping the target of decarbonizing our whole world. Thanks a lot.
Thank you, Mr. Baudu, for this interesting talk from McPhee. I will introduce Mr. Raphael Tillot. He is the Director of Renewable Energy at John Cockerill, where he is in charge of hydrogen-concentrated solar power and thermal storage solution. He also oversees the integrated energy solution, including battery storage. Mr. Tillot has more than 15 years of experience in energy sector, having worked on project and businesses development across the power and natural gas value chain around the world. He has extensive experience in Africa, amongst others having managed ENGIE's activity in Cameroon for 4 years. Please.
Okay, bonjour. Good afternoon. Thank you very much for this invitation to join the conference today. I'm very happy to talk today about Morocco, which, as you will see, is a very important country for John Cockerill, and even more happy to talk about hydrogen and specifically large hydrogen projects. A few words about John Cockerill. Who are we? So John Cockerill is in fact the largest manufacturer in the world of electrolyzers today. We are a company of more than 2 centuries. We have a turnover of 1.3 billion and have delivered so far more than 1,000 electrolyzers in the world. And we are present in quite a few places. In terms of renewable energies, John Cockerill is active on several fronts. In Morocco, you know well the solar industry. We are one of the major players in concentrated solar. As we speak, we are starting plants in South America, in China, integrated renewable systems. And of course, in hydrogen. And you see here a nice picture of one of our 5 megawatt electrolyzer stack. In terms of hydrogen, today, with our subsidiary in China, we are the largest manufacturer of electrolyzer. In fact, we, John Cockerill, as a group, we have decades of experience in electrolysis and hydrogen, as well as in pressurized equipment and gas treatment equipment. We have references in many countries, in many different kind of industries, specialized industries like chemical, steel making, power plants, and so on. We are proud to say that we already have 12 references with our 5 megawatt stack. As you know, increasing the unit capacity of the stack is one of the main levers to reduce the cost of hydrogen. Of course, optimizing the investment cost, reducing the maintenance, reducing the use of the surface. So increasing the unit capacity of the stack is very important. We have manufacturing capacity in China with today 350 megawatt per year of electrolyzer capacity. And we also have capacity in Europe, which is under construction, where we will have in 2022 a capacity of 100 megawatts per year. We focus on very large scale production of hydrogen. We are, as some of my peers have explained earlier today, working on several projects with a size of 100 megawatts. And also we are working on a project for the longer term with a unit size of 1 gigawatt. in this order of magnitude. We have just announced an investment plan of 100 million euro to accelerate our development in hydrogen. So this is R&D, this is new manufacturing capacity, among other in Europe, and this is developing new product lines of equipment. And finally, we are also active in the hydrogen mobility with hydrogen refueling station equipment. On the right here, you see a picture of our future hydrogen electrolyzer plant in France. And a final slide on Morocco. Morocco is a very important country for John Cockerill. We are in the country since several decades, but we have created our subsidiary in Morocco in 2013. We employ 500 employees in Morocco in a range of activities. We are very much specialized in providing engineering services, expertise to a range of industrial players. For instance, we provide technical expertise all over Africa from our base in Morocco. We also perform maintenance, major shutdowns of power plants in Morocco, but also beyond. We have a large workshop in Morocco where we manufacture fairly complex equipment, such as gates for locks, such as fans for very large fabrics, and the likes. And then to close, John Cockerill is very active with a range of energy players active in Morocco. We are working with major organizations in Morocco on renewable R&D as well as industrial projects, of course in the solar industry, but also more and more in the hydrogen industry. And in fact, we have already sold our first electrolyzer, an electrolyzer of 500 kilowatts to a client in Morocco. And with this, I will stop my presentation.
Thank you, Mr. Thillot, for this insightful presentation from John Cockerill. I will now introduce our last speaker of the panel. Mr. Thomas is leading globally the business development activities for the water electrolysis business of Siemens Incorporation. Before this role, Thomas was International Business Development Manager for power to gas at Hydrogenic. Hydrogenic has been implicated in most of the power gas project in Europe and is reference manufacturer of alkaline and PEM electrolyzer worldwide. Since September 2019, Hydrogenic has been part of the new power business of Siemens. Mr. Thomas focused on the Siemens hydrogen activity are on power to hydrogen, power to gas, power to mobility, power to fuels, and power to industry. Please.
Thank you, Mr. Idrissi, for the nice introduction. I'll show my screen. I think you can see my screen, huh? And you can hear me well. Thank you. Yes, so I'm here today to present the views of Siemens on this topic of industrial deployment of Power to X. So Siemens is a large international company specialized in delivering high-performance power solutions in a variety of applications in the transport and the power generation. We are today present in more than 190 countries, and we employ more than 60,000 employees. Siemens has made several acquisitions and partnerships in the field of hydrogen technologies, especially in 2019. And Siemens has acquired Hydrogenics, which is a leading and well-established manufacturer of electrolyzers and fuel cells. On the fuel cell side, we mainly deliver solutions today to the transport sector for applications such as buses, trucks, or even trains. I think one of the most emblematic reference project that we have is the partnership with Alstom on the hydrogen trains, where we supply the fuel cells to Alstom. And concerning the electrolyzer business, we've been active since 1948, and we have delivered more than 1,500 electrolyzers for all kinds of applications all over the globe. And today we have manufacturing sites in Canada, in the US, Belgium, and Germany for hydrogen technologies, and we are preparing expansion plans in new locations. I will not go through, say, presenting all the products, but I think it is probably interesting also for the participants to this webinar to see what is available today. On our side, we are active on both alkaline and PEM technologies. Our alkaline is very well suited for small-scale industrial applications, typically for clients in like the float glass industry, but also in the field of oil and fat hydrogenation, but also in power plants. And we have a number of references in North Africa, in power plants, and also in Morocco. But the main focus for us when we speak about Power-to-X applications is the PEM technology, on which we have, let's say, spent quite a lot of efforts because we believe it is the future of electrolysis technologies. And for us, the key features or what does the market need in terms of electrolysis is, first of all, a product with the highest safety standard, a product that can, let's say, cope with very dynamic operation profile to be combined with a renewable power, such as wind and solar mainly, which is the one that are going to be used mainly for Power-to-X applications. Efficiency is clearly an important element to make sure that we maximize the amount of hydrogen produced for every megawatt hour of electricity being used by the units. Obviously, cost of the technology and durability will be key to ensure the low cost of the hydrogen being produced. We should not underestimate also the question about pressure. We think that there is an interest to have technologies that can deliver a high pressure directly at the outlet of the electrolyzer. And also the footprint is something that matters, probably less in Morocco because you have quite a lot of space, but especially when we are targeting industrial application, we need to make sure that we maximize any square meter. So on our side, I will just briefly explain you what we see in terms of products and the way forward to larger applications. So today, the core of the technology is the stack, and that's where the electrolysis reaction will take place, where the electricity will split water into hydrogen and oxygen. What you see is the most compact system that you can find today. And we've started to deploy this technology in 2014 in a number of Power-to-X demonstration projects in Europe and also in North America. So you see that here the cells are placed horizontally in the system, and this unit has input a power of 1.25 megawatt of electricity and can deliver something like 25 kilograms of hydrogen per hour. When you integrate this into a complete product to actually including all the transformers to go from medium voltage to low voltage, but also the rectification of power from AC to DC, the water purification system, but also the cooling. We need cooling in electrolyzer technologies and also hydrogen purification system. Then you see the type of solution that you can actually get on the market today. For this size of application, it's mainly containerized systems that you can find on the market. But when we speak about large-scale Power-to-X application, for us, the keywords is integration, standardization, scalability, and modularity. So what we've been doing on our side was to make an upscaling of the stack that I've just presented before, and to move to stacks with an individual input power of 2.5 megawatts. And we integrate this into this type of product, which is called the Electrolyzer 1000, where you get two stacks actually producing the hydrogen and injecting the hydrogen in this balance of stack. And then you see that the technology is extremely modular. And here you see a rendering of a 20 megawatt system with 4 units of 5 megawatt each. And what you see here is typically the scope that we see for a company like us, while for the rest of the utilities, we see a key to partner with local EPC companies that can bring the local knowledge and also that can help us to reduce the cost of those technologies. Our focus has been to focus on the core components, especially the electrolyzer technology. In our philosophy, let's say bigger is cheaper. So and each time we can actually, let's say, increase the size of an individual element, it will have a positive impact on the cost of the technology. And this is also valid for the scale of the project. So clearly there is a move towards 100 megawatts plus type of project. This will really help all of us to bring the cost down of the technology because this is key to ensure the success. So today this 20 megawatts system, actually we are building it. It's in the final stage of the commissioning in a project in Canada. We, as Air Liquide, as a client, the hydrogen will be liquefied and sent to industrial clients by trucks. It is a commercial application, and it will be inaugurated in the beginning of next year. And maybe to conclude my presentation, I would like to stress the most important challenges that we see. It has been already mentioned, but the policy framework will be key to address adequately the cost gap between the hydrogen which is being produced today from renewable power and electrolysis in comparison to the hydrogen being produced today from natural gas, because it is still more expensive. And so we need to work on this together with policymakers to create a demand for renewable hydrogen and make sure that we can compete natural gas. And last but not least, standardization for us is really key, not only at our scale, but also among the different suppliers to make sure that we can reduce the cost of the technology. So we're very keen to see the interest and the developments on the topic of Power-to-X in Morocco and in the rest of the world. I remain at your disposal if you have any question. Thank you for your attention.
Thank you, Mr. Thomas, for this interesting presentation. Ladies and gentlemen, as conclusion of this session, I would like to resume in a few words the main contribution of each panelist. Dr. Catherine Godamer highlight their research projects mainly in energy system modeling, green hydrogen production, and fuel cells in vehicle, trains, and ships. She also presents HYPOS network mission objectives and projects. Mrs. Nadja Hackenson has presented Siemens solution for industrial Power-to-X deployment, particularly in hydrogen system, Power-to-X solution, and energy consulting and digital services. This experience can be very important for Moroccan Power-to-X industrial deployments. Mrs. Caroline Hillinger has exposed NG vision and expertise in the new Power-to-X markets. She highlights the challenge facing industrial scale-up of the Power-to-X value chain, vision, complementary of players, timing, regulatory framework, etc. Mr. Christopher Frank presents the smart solution for climate projects protection using RES based on the powerful Power-to-X technology. He focused on the pillars for successful Power-to-X industry deployment, legislation, framework, transparency, to guide investors, incentive mechanisms, and to attract investment, etc. Mr. Florent Baudu presents McPhee Industrial Solution for zero carbon hydrogen production and distribution. He also insists on the role of scale-up to improve competitiveness. Mr. Raphael Thillot presents the expertise of John Cockerill, who placed green hydrogen at the center of his renewable energy strategy, particularly in the manufacture of high-capacity electrolyzer. With a presence in Morocco with high added value, John Cockerill is part of the technology and industrial support of renewable energy projects, in particular in the Power-to-X field. Mr. Denis Thomas focused on the solution offered by Cummins Hydrogenic in the power-to-gas and power-to-fuel sectors. The solutions are able to bring a significant added value to development of the Power-to-X industry in Morocco. And without more delay, let us start question and answer session. The first question starts from Dr. Catherine Goldhammer. Germany has recently adopted a national hydrogen strategy. How will this affect the industrial deployment of Power-to-X technologies? In which energy sector do you see Power-to-X technology being used in Germany in the future? Please.
Yes, thank you for this question. I think, Caroline, you said it best. We need cheap renewable energy and a technology cost reduction. And obviously, Germany is not the kind of country you were thinking of when it came to renewable energy, right? But still, we have adopted a hydrogen strategy. It's about green hydrogen, so it has to come from renewable energy. And Germany is actually thinking about importing green hydrogen from other countries. But we have also set up national targets for electrolyzer capacities in the range of 5 to 10 gigawatts over the next 15 years. So what this tells me is that obviously the hydrogen strategy is addressing the technology cost reduction in the sense that they're trying to invest in projects, thinking that this will drive the costs down. And also, when you're asking about the energy sectors where I see hydrogen coming up, this can also be related to the German strategy, because in the German strategy, the decarbonization of the industry is the first focus point. So we're looking into the next 10 years or so, the German industry, and then after that, the transport sector and heating. So the order of priorities in Germany will be the industry, and then the transport sector, and then heating and other energy uses. Thank you.
Thank you. The second question for all the panelists. What are the challenges facing industrial scale up of the Power-to-X value chain? Who wants to answer, please?
Maybe I can start.
Go ahead, please.
Go ahead.
Yes, I think what we are really facing today is that there is a huge expectation, in fact, on the market and on the paper for our technologies. So everyone is expecting to buy today, or actually preparing today, very large projects, but those are only going to be really decided in a couple of years. And so this is extremely challenging actually for the industry today to actually commit already on those type of projects. So I think that that's clearly one of the challenge. Obviously, one of the solutions to this challenge is a collaboration together with the project developers, with energy utility companies, like the ones that are present to this meeting, to actually ensure a good visibility on the project pipeline in terms of size and the moment at which those electrolyzers will be needed on the market. The second one is clearly cost, and is linked with this challenge of scale. As I mentioned, bigger is cheaper. And so we need volumes actually to invest today in gigawatt factories. Actually, we are planning today first gigawatt factory, but when we see what Europe and also leading regions are planning, will need hundreds of gigawatts. And this is going to be one of the main challenges together with the supply chain, to ensure that the rest of the supply chain will follow in delivering the large quantities of electrolyzers which are needed for this market expansion.
Yeah, I can only add to that in agreement, of course, what you just said. that ultimately one of the bottlenecks will be the manufacturing of electrolyzers. That's for sure the key, but that will come up in the next years as soon as the market is developing. But again, getting the energy to Europe or to the industrialized nations or to the highly industrialized nations, I think the energy transport is another bottleneck that we have to focus on. Right now, there are initiatives on using methanol as an energy carrier. The commercial ship industry, for example, could be a huge potential off-taker. Methanol is considered to be non-hazardous to the maritime life, so you can use the double hulls of the ships as a tank, as an additional tank. That could quickly come. We know that cruise ship industries, ferry industries think of hydrogen as a fuel. That's all okay as long as the hydrogen is renewable. And I think one aspect we should focus as well, in particular here in Europe, where let's say the availability of renewable energy is limited. Although it might not be very popular, but I think the so-called blue production of commodity chemicals is also an option, because it can, as an intermediate step, can provide extremely large quantities of hydrogen with conventional technologies like autothermal reforming, steam reforming, etc. And then the only thing you need to do is to separate the CO2 and, of course, either give it to other, let's say, chemical value chains on one hand, or to sequestrate it. I know here in Germany it's a no-go from the public opinion-wise, but if you look at Norway, for example, or if you look at the UK, there's not a no-go. Yeah? So you can use depleted oil fields, gas fields, as a potential storage of CO2. Compression of CO2 is standard. It's also no rocket science, can be easily applied. And the advantage is, for a transition period, you can supply CO2-free enormous amount of hydrogen without this larger transportation problem. We can use many of our pipeline networks here in Europe and elsewhere in the world as well, wherever you have gas pipeline networks and grids. You can convert these either to a pure hydrogen service, or you can use it by mixing additional hydrogen to the natural gas, for example. So that's another aspect besides the electrolyzer, which certainly would be an option to provide very quickly CO2-free hydrogen at a large quantity for a transition period. Thanks.
I can also add also from my side that I think, we talk about the supply chain and scaling up the technology and so on being one challenge. Of course, this is obviously a challenge, but the key priority challenge is the off-taking, the business model. That, this is still very expensive technology needing a lot of investment, and it's really great that countries such as Germany is heavily investing and focusing on this, and seeing also the international component of importing green hydrogen from countries such as Morocco. And I think that all of this just needs to, in a harmonious, simultaneous way, all happen at the same time, so that there is a clear business case also for those who actually take the risk and invest in this new field of energy.
I can only support what you have just said. It all starts with the customer. And the customer is for sure the off-taker. While in developing this new industry, it's about building the partnership on the full integrated value chain. And to make a project fly, for sure technology is helping. For sure the good cost of renewable is helping. Combining different sources of renewable, is it solar, is it onshore, offshore? With offshore having 55% load factor, that's helping a lot the business case. Giving a second life to assets, is it pipeline, is it the industry, it all helps to bridge the gap, and maybe cherry on the cake if we target an industrial cluster or an ecosystem where we stack the different end users, we can come up to a scale. And to do that, it's a new way of development. It's aligning and joining forces, thanks to also the political support and the political willingness to move ahead. And that makes country like Germany, to come back, Catherine, on what you said, a great country to do so. That makes Morocco a great country to do so. And that's joining forces will make it happen.
Yeah, if I may add to that, Caroline, it's not only there, but there are elsewhere in the world huge efforts underway. If you look at Australia, I think RG is active in Australia as well, as far as I know, and even Saudi Arabia is extremely active in that field, which is maybe not that much popular and heard of in the Western world, but they are doing extreme things there with huge investments. So I think our mission is moving forward, if I may say so. But as also Nadia said earlier, I think the political framework is absolutely necessary. We see that in Germany, we see that in France, and let's say in Western Europe, all the way down to Spain, Morocco certainly as well. But there would be much more countries could be helpful there. If you look for Egypt, for example, I know they are developing something like that as well. So everybody's coming up, but we need velocity, I think, in that. And that's only possible if there is some political pressure also applied to the systems, to the economical systems, in order, if I may say so, to twist some arms in the industry to redirect maybe some of the investments. I think that's happening here in Europe, at least. In other countries, we at least hope that this is going to happen as well.
I mentioned Morocco as... sorry, Raphael. I just wanted to add, I mentioned Morocco to thank our host and also as natural partner, because being very close to Europe with very good renewable resources. But for sure, it's happening everywhere. Sorry, Raphael.
Thank you.
And a nice gas pipeline going to Spain.
These projects, large-scale projects in hydrogen, are relatively new and they are complex. And if we want to make them happen soon, fast, we need to find a good balance between being local and being global. So to find the right partners, to bring the complementarity between this local dimension for Morocco, which is key to secure this project, to secure the permitting of the project, to secure also the labor, the workforce for the construction, for the development, for the maintenance, and to combine that in a more global dimension to get access to the best equipment, to the cheapest equipment, to funding, possibly to a market for the export. So for us, the partnership dimension to make it a win-win is really key to go fast.
Thank you.
If I may just add to what was said, indeed fully agree with what you've just said. And, building those partnerships, one thing which we see also by experience, you mentioned that, all of you, during your previous speech, we need to have this holistic approach. So we need to put together members of the ecosystem which are coming from different culture. They have different habits and different internal mechanisms. They don't always speak the same language. And they need to be brought together to make these projects working and this ecosystem developing. And it also requires from time to time to make sure how you will structure the rules of working of those, let's call them a consortium, whatever, so that the governance of these small consortium you bring together works in an efficient way, which would make the project coming from just an idea, a concept, then industrial implementation and final investment decision positive, actually, which is not always easy. And that's also one of the key within this project as we see it.
Thank you. My question now is addressed to Mr. Florent Baudu. What are the key drivers to bring scale and impact to industrialization efforts and to achieve a further cost reduction and competitiveness? Please.
Thanks for the question. we do believe that at the end of the day, it's a kind of role game, let's put it this way, to be a little fun, which has to be played by the three sides of the force, if I may say so. When I mentioned the three sides of the force, these are the one I mentioned in the presentation, the industrial and investors, the public authorities, and also the equipment suppliers. On the first slide of the presentation, as you have seen, the axis scale was the twin scale, where you could see at the same time the timeline and the installed capacity to allow the scaling up and the drop of the cost of the electrolysis and production of hydrogen, because they have to go all together. We cannot separate the timeline and the installed capacity. It will work in the expected timeline if the projects come and if indeed they are turned from concept to real project after positive final investment decision. And this is the sole way that all the timeline and the installed capacities or finally decided projects will come to reality, will drive the cost and the scaling up in the right direction. As well, and this was not reflected in the slides, but we do strongly believe that the curve will not be, as you've seen that on the presentation, a smooth curve with a kind of decreasing exponential curve, but some technological thresholds, typically it was already mentioned, bigger equipment size, bigger equipment capacity will clearly rupture the slope of the cost reduction, which will participate to reaching the targets which we are ultimately focusing on. And then, of course, it was tremendously mentioned, but the right amount of subsidies, but at the right place, will be important. The subsidies shall not be a blank check, and they shall help launching the rocket, to be used like boosters, but then the rocket should fly by itself when we have reached the right scaling up level. And this will make all of us around the table as equipment supplier sweating, for sure, to focus our efforts to the right place and to reach these targets. It will not be easy, for sure. We all have our path and roadmap to reach this target, but as I would say, there is nothing which is gained with no suffering. We will have to suffer somehow in our organizations, but that will be the key for us to reach what the market is demanding to make the whole ecosystem fully sustainable.
Thank you, Florent. I think if we want to respect the time, we will stop now. Thank you again for all the panelists for their interesting presentation. Thank you for the organizer. Amen. It's you.
Honorable Chairman, for this particularly insightful session. I was not surprised by your ability to chair this meeting and to summarize the important insights we gathered. As president of the Moroccan Energy Federation, I'm sure you are quite used to this very constructive type of remarks. We have discussed the real economy in essence. Following the earlier sessions, we were able to consider concrete experiences, concrete products. We discussed challenges, success factors, we discussed ambition, and we also discussed what is possible already. We differentiated between technology and technology adoption. And we also took into account the fully integrated value chain of what we're discussing. So thank you again to the chair and all the speakers for these most insightful remarks. One of the speakers mentioned a cake and the cherry on the cake. We have about 20 minutes before the next session. I am not sure if it's enough time to enjoy both the cake and the cherry on the cake, but make sure to at least have some coffee so that you can continue to be intellectually mobilized and stimulated for our upcoming session at 4:30 with Irina, discussing the hydrogen collaborative framework. Thank you very much. See you in a bit.